Hey everybody, the purpose of this little video is to get us some solutions to the central tendency quiz. This is the one about Old Faithful, so we'll have a good time with this one, I think. First question is, how many observations are represented in the histogram? So how many observations? Well, let's see. We've got a time from 55 to 60, 60 to 65, 65 to 70. So it looks like there are 3 times between 55 and 60. You may have noticed I've opened up Excel over here. I'm going to go ahead and start typing into Excel. I'm going to keep track of those times. Now, you might notice what I'm doing here. I'm keeping track of the midpoints of each of those intervals. I'm going to call these the X's or the times. Let's even get fancy. These are the times in minutes. Let's center this because I'm kind of a dork about centering. 67 and a half, I think. 62 and a half, 67 and a half. I think Excel's smart enough now. If we drag this down, it's going to continue the pattern. Look at that. It sure did. Once you get 3 in a numerical pattern, it'll continue the pattern for you. And then here we're going to have the number of each event: 3, 5, 3, 2. Looks like we're up to 7 on this one. 12 is the mode out there at 82.5. 10, 92.5. These are both 3s, it looks like, and then finally a 2 right there. So there's your beautiful little data list with its frequencies. Throw an underline under there just to be saucy. Let's insert a. There we go. Looking good, friends. Okay, so beautiful. Here we go. So the number of observations is going to be the sum of this. Now, Excel's kind of tricky. If you draw a box around it like that, down here at the bottom, it actually tells you that the sum is 50. I don't think you can see that in this video because I think it's looking at too small of a space. So what I'm going to do is, in this cell, I'm going to do equals sum. And equals sum, boom, boom. So what I'm going to do that too is I'm going to make sure everybody can see what I just did. I'm going to do, let's see if I can figure out how to do this. It's a very minimized screen, but I'm going to put some notation in here. Where's big sigma? Sigma, close that. Sigma f equals. That way you can see the summation of the frequencies is equal to 50. We just added up the frequencies, it adds up to 50. And of course you can do all this manually. I'm just using Excel because it's easier than trying to remember numbers in my head. Okay, beautiful. That was the first point. What is the average length of time before eruption or between eruptions? So, just like in class, this is a weighted average. Although you have these data points right here, you've got 10 data points. You actually have 50 because some of them occur multiple times. So as we figured out in class, we need to add up the X times the F column. So the first one has to be the 172.5. This next one down here about 190. Excuse me, that was 5, not 3. And we drag that formula all the way down. This is actually the total number of minutes accounted for by all of these times this frequently. And then what we need now is we need another column, another computation. Whoops. Interesting. Hang on one second, friends. Oops. Oh, I'm screwing things up now. Hang on. I'm trying to be all slick and put the symbol for summation of X times F here. There we go. We now need to do an equals sum of all of this. So if you add up all of those guys right there, that's the total number of minutes that we waited between eruptions in this set of observations. So your average is going to be equal to this guy divided by that guy. So it's going to be equal to that divided by that, which ends up being 80.3 minutes. That's your. I didn't tell you what to round to, so don't worry about it. If you said it 80, if you said 80.3, it's all good. All right. What is the median length of time between eruptions? Now, Excel does not know how to do medians of grouped data, so we have to be a little bit slick with the median over here. We have to do some chopping. So we're going to chop off these 3. I wonder if I can get a. I don't think I can. Yeah, you know what? I can. Let's do this. Take a screenshot of it. There we go. This is a snipping tool. If you've never used it, it's pretty slick. Let me grab a pencil. Here, we'll do a red pen. All teachers like red pens, right? And get a big fatty red pen. Oh, that is. Oh, we got different colors? Oh, let's make it dark green. That's good. All right, so we're going to do this, and we're going to chop. So I'm going to chop off 3 of the lowest pieces here, and that chops off 2 of these. That means I have to chop off 1 of these, 1 of the 3 here. So what I'm doing is I'm chopping from the top and the bottom. I've got to chop off 2 more here to cancel that bar. I'm going to chop off 2, 5, and 4 to cancel this bar. I now have 3 left in this bar. Chop, 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 chop. I'm honing in on the middle this way. I'm going to chop these 3. 1, 2, 3. I've got to chop off 3 of these. 1, 2, 3. That leaves 7 behind in this bar. I'm going to take 2 of them right here. Now with 5 left in this bar. There are, let's get rid of those 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And now I've got 2 left in this bar. 1, 2. Take 2 wherever in this bar. And now I've got 10 left in this bar. There are 10 left, which means no matter where I chop, I'm going to be chopping in this bar. So that's the logical. We are now in this bar. Our median is in this bar. Okay. So since our median's in this bar, that means we can just call 82.5 the median because the bad boy is in that bar. We don't have to worry about anything else. So as far as what the median length of time is going to be, it's going to be 82.5 minutes. All right. Yellowstone Rangers in 2001 told me, my goodness, it's been a long time since I've been there. Old Faithful erupts every 80 to 90 minutes. What percentage of the intervals are between 80 and 90 minutes, assuming that the data above represents a good sample? Okay, so assuming this is pretty indicative overall of what would happen if you sampled more. Well, here's 80 right here, and here's 90 right here. So there are 12 at 80, or excuse me, 12 at 80 to 85, and there are 10, which gives me an altogether a 22. That's 22 total out of 50 observations, which percentage-wise is the same as 44 out of 100. So the answer to that one's going to be 44% of the time. 44% of the time, we land between 80 and 90, as per the Yellowstone Ranger. Okay. Letter part E, what percentage of intervals are less than 80 minutes? That would be all these guys over here. Less than 80 minutes. So let's see, that's 7, 9, 12, 17, 20, which would be 40%. Which is, so you got 40% here, you got 44% here. Next question is, what about more than 90? Well, if we had 40 and 44, altogether that's 84. That must leave 16% left. 16% are more than 90. And now, so that's the 3 numerical answers for C, D, E, and F. Number 2 here, or the letter G, based on your answers, do you think the name Old Faithful is appropriate? Your call. Your call. I mean, there's going to be all kinds of solutions to this one. Based on my answers, I think we've shown that Yellowstone Rangers belief is a little bit skewed. I mean, Old Faithful erupts every 80 to 90 minutes. Well, not really. It erupts less than half the time between 80 and 90 minutes, or right around half the time. Based on that, Old Faithful, I mean, you're not waiting any more. There's the variance between the lowest 55 and the highest 105 is 60 minutes. So you're waiting no longer than an hour. Compare that to some of the geysers, like Texas Geyser, which don't go off sometimes for 5 years, and this thing seems as regular as a pocket watch. So I'm kind of curious to see what you guys say about what you think Old Faithful should be called. So anyway, there's some solutions to our quiz, and I hope you found them helpful.